Okay, so in this question, we have some cliff jumping going on at a lake here in BC and looking at mapping out how he travels down into the water from the cliff top. And so we have an equation here, and so that equation we'll probably want to go and put into Desmos and see what that looks like. And then we have a few questions to answer related to that graph. So again, to show our work, best way to approach this is to draw that graph that we get from Desmos. And then that way, what we can do is we can show our understanding on that graph. And so, quick sketch here, it might look something like that. It's a little more subtle on the top there from the graph, but this gets the main point in there. And we have the two X-Intercepts. They don't land right on an area. This one is just before 1.5 here, and this one's just before 0.5. So definitely leaning to the right on this graph here. Our x-axis, in our case, is our time in seconds, and our y-axis is our height in meters. And we can also point out that this right here crosses through at 10, and that would be 10 meters, and then it seems to go a little tiny bit higher than that to the right. So now let's think about this for a second and recognize that if we were to watch somebody jump off a cliff and kind of map out their path, this part over here wouldn't make a lot of sense. And that's totally true. With time being a negative, well, that's not going to make sense in the real world here. So what we do is we say, this is a mathematical model, and we have to use our smarts to look at it and say, where does this model represent reality and where does it not? And so here, between 0 and the time that they hit the water, it certainly represents reality. So that's the part that we can focus on as the model that overlaps with our reality. So let's see what we can solve here. Number A, or part A. What is the height of the cliff? Now, we can look at the graph and we can say when time equals 0, he's standing on the edge of the cliff. So this represents that initial point when he's just about to jump. Now, in this case, it looks like he jumps up a little bit, so he rises up from that point. But the bottom line is where that Y-intercept is where we start off. So Y-intercept, or when time equals 0, in other words, just justifying our way of thinking about this, we see that y is equal to 10 meters. Now, another way to answer that one, somebody may come along and say, well, why don't we just plug t equals 0 into our equation? And it's actually surprisingly easy, just because if we take a look at it, 0 squared plus 0.5 times 0, and anything times 0 is 0, right? So that means this is all gone, and we're left with 10. So either way is perfectly good to justify how you determined what the height of the cliff is. Okay, on to part B. And part B, we're saying what is the highest point that Mackenzie reaches? Now the highest point is right there. In other words, he jumps up as he jumps over the edge, and so he gets a little bit higher than the edge of the cliff before he starts falling down. And so we can say the vertex is at, and if we on Desmos, we can click on it and it'll tell us 0.05 and 10.012. So the 0.05, that's the time, and the 10.012, that's the height. And so our max height equals 10.012 meters. So yeah, he just got a little tiny bit higher than the edge of the cliff as he jumped out, and there we have it. For part C, we're asked how many seconds until he hits the water. So from there, we can say that the Y-intercepts are at 0, or no, they're at 0, well, okay, the y-intercepts are at negative 0.5, but we'll cross that out because it's not really reality, and we can say that his traveling time goes from 0 to, and the other X-intercept on Desmos we can see is 1.465 seconds. So from 0 to 1.465 seconds is a total of 1.465 seconds. And we're all done.